Hey there, physicists. Welcome to part two of the vector addition example video. We're going to do a second example. A ball is moving 25 meters per second horizontally and 15 meters per second downward. What is its total speed, magnitude, and direction? So here we go. 25 meters per second horizontally. I think I can draw a picture of that. There it is. I want to make this. So this is its, I guess this is its Vx because it's already. And now we have a Vy as well. Vy is not as fast, 15 meters per second downward. Vy equals 15 meters per second. And this is, in this problem, we can make y positive downward and we can make x positive to the right. So we get positive numbers in both. Now, basically, we just need to be able to add these up and make sure. So we don't need to resolve any vectors because they're both purely in x and y. And so we don't need to do that. We don't actually need to do any adding because we just have one x component and one y component. So all we need to do is jump to step 4. And so I think I'm going to be a little bit tricky here and just, well, I'm going to redraw it because I have to make a right triangle out of this. So there's my, oops, come on now. There's my 25 meters per second. Okay, 25 meters per second. Okay, Vx. And I'm going to move this over a little bit so that it's tip to tail. And this is Vy equals 15 meters per second. And why wasn't it okay to do this over here? Now I could have done that and I could have made it into like a right whatever you call it, a parallelogram like this, right? I could have done it like that and then figured it out. But I prefer to have my two vectors lined up along tip to tail like that. And so here's how I'm going to do this. This is V, right? So this is the magnitude of the whole vector here. And I'm going to make, just for consistency, I guess I could call this phi as well. This angle here, phi, just like I did in the last one. This is a right angle. And of course, we don't want to forget the heads of our arrows, very important. There's a head on that arrow. There's a head on that one. There's a head on that one. Any legs that are hypotenuse here with no head on the arrow, we don't know which way the vector is going. So you have to label that. Super important. All right, so we're going to do the Pythagorean theorem again. It's going to be 25 meters per second. We're going to square that whole thing, including the units. And we're going to also add on 15 meters per second. Square that whole thing, including the units. And we will see what we get. All right, here it is. Square root of 25 squared plus 15 squared. It looks like we got 29.15. I'll give it a little more, 155. I'll put one more on there because I don't want to have a round off error. Now I will round my final answer and I'm going to round it to 3 digits. So it's 29.2 meters per second. So that's the total speed, right? Again, that's the magnitude of the vector v. Now we can find the angle here, which would be the arctan or inverse tangent of opposite 15 meters per second over 25 meters per second. And we'll do a little meter per second cancels out. Also, I forgot to cancel out units here. Meters squared over second squared plus meters squared over second squared combines into meters squared over second squared. Take the square root of that, get meters per second. All right, checking out those units. And we're going to find our final answer here. inverse tangent of 15 divided by 25. And that gives us 30.964. 30.964 degrees. That's approximately 31.0 degrees. We round it to just 3 sig figs there. Okay. And we will say we need to provide it not just an angle to describe the direction. We could say that that is 31.0 degrees below the horizontal. Below the horizontal. Okay. All right, guys. So remember, when you're doing the vector addition situation, you don't have to do every step all the time. You only have to do the steps that are needed in the situation. Okay. Hope you enjoyed it. See you in the next one. Good luck with all the physics.